Right. So last time we start discussing introduction to computer. So we discuss what is computer is. So basically computer is data processing device. Okay, so that is the first thing you must know when it comes to what is computer is. So then we discuss that computer process conceptual data, and also computer can process different type of data. Numeric data, textual data, images, audio, video. Okay. And also there are so many other sensory data that computer can process. And then we discussed that the computer use layered architecture. So we can look at the computer as set of layers, hardware, firmware, software, and liveware. Okay. So hardware is the physical stuff. Firmware is theoretically software, but more related to running the hardware. So then you have the software programs. And software is subdivided into system software, predominantly operating system, and application software. And for the users. So that is what we discuss. So I'm just doing quick revision. And your data goes through the application software to operating system, to the firmware, to the hardware, and get processed at hardware level, 1.0 level. And then the results are displayed in the application software so that the users can see the results. So that understanding you must have. And if you have any doubts about that, you can ask. Of course, still you are learning it. Okay. So then we discussed that computer is some features of computer. Of course, computer can process different type of data. And computer represents everything in binary. For humans, we look at different things in different way. For us, numbers are different to text. Text is different from image. Image is different from audio. Audio is different from video. And we remember things in different ways. But computer store everything as set of ones and zeros. Everything. So those are the basic things you must be very clear from day one. For computer, everything is set of ones and zeros. Whether it's image or audio, video, or text. Right? What else we discuss? So then we discuss that how does computer represent everything in zeros and ones? So there are two different type of things in this world, quantitative things and qualitative things. Computer quantify everything. So I'm just doing a revision, what we discussed last time. For computer, everything is a quantity. Even image is a quantity. Letter A is a quantity. And then convert it to binary quantity or binary number and represent it. So that is why everything is set of ones and zeros. Okay. So while it's getting processed also, it's at that level, binary level. So therefore, we can say that computer is a binary digital electronic device. So then we start, of course, that binary came from there. Binary digital. For computer, everything is set of ones and zeros. So then we discuss that computer is an electronic device. So we subdivided different ways, devices, right? Manual things, mechanical things, electrical things, electronic things, biological things, like a cow. So we can use cow also to do certain things, like getting helps. So computer is a electronic device. So what is electronic device? A device that either generate signals, process signal, or consume signal. Right? So signals are something like this or something like this. And computer is not only electronic device, it's a binary digital electronic. It's a digital electronic device. So that means it process and transmit, generate this kind of signals, not this kind of analog signals. So therefore, computer is what? Computer is a binary digital electronic device. For computer is everything is set of ones and zeros. So in the computer, all these data is transmitted as this kind of signals, not this kind of signals. So that is what we discussed. I think for the whole session, last week, all 2 hours, we discussed about this. Okay. So therefore, computer is a binary digital electronic device. Okay. It stores data in binary digits, process data while it is in the binary digits, and transmit also in as a binary digits. So we discussed the difference between electrical and electronic. Electrical devices use electricity as a power and mostly convert it to heat, mechanical kind of a different energy. But electronic devices generate, consume, or process signals. And digital electronics devices generate, consume, and process digital signals. And of course, our computers are binary digital electronics. So therefore, it process, generate, consume binary digital signals. Right. So we discussed the difference between analog and digital. Right. And some pros and cons of analog signals and digital signals. So the digital signals are, so engineers love to work with digital signals, but unfortunately, nature prefer to transmit analog signals. So nature doesn't give good support to transmit digital signal. So therefore, still when we transmit, we rely on analog signals. But the moment you take it to the device, we want to convert it to a digital signal, because digital signals have, it's easier to process, easier to store, it's more reliable. So this is the first thing you must understand. Otherwise, you will never ever understand what is computer is and how the computer process data or the philosophy behind computer. Otherwise, you will just blindly memorize things. And again, if you have any questions, do you have any questions about what we discussed last time? Any questions means something not very clear, something you like to get a little bit more clarification, something you need a little bit more details, anything like that? Because remember, this is a technology subject. So therefore, it's every day we build little bit more knowledge, and it's all about confidence. If you lose somewhere, so that's the end of the story. So you can't, when the exams are nearing, you can't study. No, that is not going to work for this subject. Okay. Right. No questions, nothing. Everything is clear. Okay. So what are the key advantages of binary digital signals? Though it is difficult to transmit, almost impossible, long distance, but when a signal distort, we can restore it to the perfect sort of a level. We know that because we have only two states. Two state, voltage tend to deteriorate. But when it deteriorates, still if it is not zero, we know that it is what? We can restore it. So that is something you need to understand very, very, very well. So that is why these are very stable, right? So when they say, yes, I got it from computer, it is processed by computer, no one has no doubt, right? Right? You have no doubt about going to the ATM machine and withdraw money. You have no doubt using computer or internet to do certain things. Why? It's so reliable. So reliable. That is because of the digital nature of the data we process. So if something deteriorate, we can again restore to the perfection. But if it is analog signal, if this got deteriorated like this, now how do you restore it to the exactly this level. So we have no clue. We have no clue whether it should be like this, or whether it should be like this, or whether it should be like this. But here, because we have only 0 and 1, if it is not 0, even though it is like this, we know that, okay, we must restore it to 1. So I'm keep repeating this because this is what make computers really, really, really reliable. That is why engineers love to work with digital electronics, not analog electronics, because they can build very reliable systems. They can do very reliable processing. Okay. And also maintaining two states, especially storing, it's super easy. Super easy. Just 1 or 0. There are so many mechanisms like magnetism, north polarized versus south polarized. Right. So now let's move on to, so we are now into more serious stuff. Okay, more serious stuff. Of course, now we are into the serious stuff. So what is mean by processing? Still, you don't know exactly how something is represented in ones and zeros, right? That is our third topic, representing data in computer, right? For example, I know that you, unless you have done a bit of ICT, you don't know how something like hello is represented as set of ones and zeros. Of course, this can be represented as set of ones and zeros. How do you represent this kind of a image as set of ones? And of course, there are ways. And when I talk, how do this signal, my audio represented as set of, just assume there's a way to do that. There are ways to do that. So that is our third topic. So in our third topic, representing data in computer, yes, we will look at it. Now just assume that, yes, there's a way to do that. Okay. Which will cover in topic 3. So topic 3 is data representation. So now we are in introduction to computer, okay? So data representation. So then topic 4 is how the data is processed, okay? But just assume you know there's a way to represent data, any data, whether image, audio, video as set of ones and zeros. So binary numbers. Now, what is mean by processing? What is mean by processing? Because computer is a data processing device. So computer represent everything as set of ones and zeros. So then how do we process this data into something else or get your results, information? So today itself, you must have a little bit of idea about it. What is mean by processing? So can someone tell me, according to your understanding, what is mean by processing? I'm not expecting correct answers. Of course, if you can give me a correct answer, I will take it as a bonus. According to your gut feeling, just if say you want to say something, what would be your answer? What is mean by, or how does data computer process data? According to your very basic understanding, getting the information or results. So I told you I am not expecting correct answer. If I get a correct answer or sort of a good answer, correct answer, I will take it as a bonus. Okay. So no one. Or you can put it into chat if you are really, 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 really uncomfortable talking. So you guys are asking for more and more opportunities, right? තරුණයන්ට තැන දෙන්න. So this is the opportunity. So you guys are youth, right? In about one year. No one? What is mean by processing? Or how does computer process data? So there are two answers. There are two answers. So remember, we can think of computer as layers. Hardware, firmware, or maybe system software and application software. Let's take together software, just for simplicity. Software, right? So anyway, let's see what is your answer is. Transformation of input data into information. Yes, that is my question. So what? Yes. Anyway, that is sort of a correct answer. My question is, yes, I think I didn't ask you the question proper way. That is why I have to accept your answer anyway, because actually I thought one thing and I asked slightly different thing. So what I ask is what is mean by processing. So therefore your answer is perfectly correct. So now I want to change my question. Actually it's my mistake. How do you feel like, how does computer process data? How? Not so according to your understanding, how does computer process data? I need a very high level, simple answer, not a very technical, detailed answer. Just maybe a simple sentence, few words. How does computer, or what is mean by computer processing data? Or what is the, how does computer process data? Think about it. So when you think, so that gives you that additional confidence, right? So it's all about once you start thinking, so all your problems are solved. So then you are into the study. Anyone? So when I give you the answer, you will be really maybe upset. I should have told that answer. You will feel like, so that is why I want to give you that opportunity first. Maybe I should have given that kind of answer. My question is again, don't think too much. Don't think too much. I'm asking simple question, basic question, a question that even grade 6 to 7, grade 8 student must be able to answer. Of course, you are not grade 8 student, or maybe maximum grade 9, grade 10 student must be able to answer. I'm not asking advanced questions. Of course, then I must be stupid. But of course, different students can give me, they can look at it in a different way. That is why I told you there's nothing for this is the correct answer. Anyone? No one? How does computer process data? So you can give two answers. Of course, you can give different answers the way you look at it. So remember, we can look at the computer as set of layers, hardware, firmware, software. If you look at it in software level, you can give an answer. What is that answer? So we have data, we have software. The software is program. So what is program? Now you have to think. So we have software, we have data. So we input data. Remember, we input data to the software. And what is software? Oh, another name for software is program. So basically, what is program? Can someone tell me, according to your understanding, what is program? Do you think that I'm asking unfair questions? Someone in 2024, after schooling for 10 years, with so many ICT teachers, ICT subjects around, uh, according to your understanding, what is a program? Computer program. Because software is another fancy name for program. So if you start talking, we can do it fast actually. I prefer to finish it in one and a half an hour. Not 6. I want to finish it in 5:30. Definitely sometimes I finish classes in 5:30 because students are very cooperating. So don't ever think that I want to extend this to 3 hours, 4 hours. No, I'm keep thinking of, can I make it into a 1.5 hour, 1 hour class? Because I know that attending classes is not a right. So when I was in the school, I was doing my A level and so on. I prefer to play cricket, not attending school. I prefer to fly kites, roam around. So that is why I want to make it short, because give you the guys freedom, but you must be collaborating. Set of ordered operations for a computer. Correct. That is what I was expecting. Actually, I was expecting a simpler answer. So program is the way we ask, basically programmer write the instructions saying this is how you are supposed to process it. So that is what program is, right? So basically program is a person, software developer, programmer telling the computer, this is what you are supposed to do. So therefore, what is mean by processing? Your data at software level, your data is processed, okay, according to the logic written by the program, according to the logic written in the program. So that is one way of looking at what is computer, how the data is processed. So when the data is processed according to those instructions, you get the result for the information. So that is one way of looking at it. Actually, that is correct. That is why you write Python program, Java programs, C programs, and so on. Okay. So that is one way of thinking what is programming is, or what is how the data is processed. Okay. So you have program written by programmers, and maybe you are running it in the computer. So your data is processed according to the logic written in the program. So that logic has been written by the programmer. And then we get the result. So maybe the program says, take all the inputs and calculate the average. Sum it and divide by number of elements. So then when your data is 10, 20, 50, 80. So here you get 80 plus 10 plus, sorry, 10 plus 20 plus 50 plus 80 divided by 4. That value is given as the output. So your data is processed. So that's simple, right? That's super simple thing. Right. But if you go into the low level, because remember, program is a conceptual thing. Conceptual thing. So how does these conceptual things happen? How does my program execute this data? So therefore, this is in a way correct, but in a way, this is not a correct answer. Because in reality, how do you explain to someone? Then someone will ask, okay, I can understand. You guys write a program and yes, data is processed according to your logic. But how can a program execute data? I can't understand how it is really happening in the computer. I can understand you input raw coconut and water, and then I can see it's getting processed and getting the water, coconut milk, because there are blades. I can see the rotations. So right, someone will say that, okay, I can understand how you process your raw coconut and water into coconut milk. But still I can't understand, well, how do your data is processed by your program? Are there people inside the computer executing those lines line by line? Or is it a physical thing? Are there any mechanical things? Are there any gear wheels? Someone can ask, right? So that is where you need to go into the low level and explain it again. Yes, at high level, this is perfect answer. Your data is processed according to the operations written in the program is applied, like add, subtract, divide, and so on. But how do we do that? Because as humans, yes, we can add, subtract, multiply, divide, and so on. But how does computer do it? So that is where you need to get into the low level, low hardware level, and explain. Hardware level and explain. So at hardware level, your data is not anymore 35 or image or sound. It's set of ones and zeros. So the way we do it, we will discuss in topic 3. So then what happens? after processing by hardware means your motherboard, SSD, hard disk, microprocessor, and so on. So it's getting processed by hardware, and you get different set of ones and zeros. And these different set of ones and zeros represent your result of information. Maybe these set of ones and zeros represent 10, 80, 30, 50, and maybe this represent the average value, maybe 40.10, 40.5. So this set of ones and zeros must represent your final result. So that is what happens at low level. At low level. So this is high level. Okay, right. So then how does this is transformed to that? So that we will learn in your levels, your end of the topic, this particular topic 2. So you have subtopic called computer architecture. Computer architecture. So again, I'm keep referring to your syllabus. So you can see here you have introduction to computer, file handling, process handling. Okay. So how does data is processed? So that is where we are going to discuss that. Okay. How the data processing? So that is, sorry, not process handling, sorry. So it's in your topic 2, computer architecture. Sorry for that. Okay. So still we are in the introduction to computer. So in computer architecture, we will discuss further how does your program is converted to your data. Rather than your programs running it, how does your computer process your ones and zeros at the low level? Okay, in detail. So therefore, now you can explain it in 2 levels. You can explain it in this level, that is at software level, or you can explain it as something like this. So your data is set of ones and zeros, which are transformed, or either those data is transformed or new ones and zeros are generated in your hardware level. And this gives you the result or the information. And this is getting processed. So how is it going to process? Of course, it is going to process according to the logic you have written in your program. Otherwise, of course, this doesn't make sense. Right. So this processing must comply with the logic you have written in the program. That is obvious, otherwise it's useless. But how does it exactly happen? So how does it happen? Basically, you apply either Boolean logic operations or arithmetic operations to these ones and zeros. So you have set of ones and zeros. Right? And what is mean by processing at hardware level? Either logic operations or arithmetic operations or both are applied to these set of ones and zeros in a particular manner. And that is where you get this resulting ones and zeros. Maybe that is your average value, or maybe that is your formatted image and so on. So that is why your processor has compute. Of course, the processing is done by microprocessor. That is why your processor has a part called arithmetic and logic unit, ALU. Sometimes you may have heard it. And the other part is control unit. So this ALU, why do we call it ALU? Because it can do arithmetic operations, it can do logic operations. So arithmetic and logic operations are applied at this 1-0 level to get the different set of ones and zeros. That is your result. And these results can be interpreted at higher level, software level, as your expected output. Okay. I know that still you are not 100% sure about what I'm talking, but yes, you need to start somewhere. So I'm telling you the reality. First of all, you must know that what is the reality. So then only you can start thinking about it. Okay. So now you have 2 levels of answers. At high level, your program data is processed according to the program to get the information or the results. At low level, your data is set of ones and zeros, Those are processed by applying arithmetic and logic operations. Which hardware device does it? Of course, your ALU or it's part of the microprocessor does it to get the result, resulting ones and zeros. That is your result. That is your information. Okay. So then someone will ask, how do your processor apply arithmetic and logic operations? Arithmetic and logic operations at hardware level. That is a very question, right? So I told you that we have set of ones and zeros, and we apply arithmetic and logic operators to these set of ones and zeros to get different set of ones and zeros, and that is your result. If this is 5 and say add, and this is your 10. So this represent 10. Maybe this is 5, and this is saying add, and this is your 10 in binary. So that means how do you do that? You apply either arithmetic operations and logic operations. That is why we have arithmetic and logic unit ALU. So I'm just building a story. Actually, it's not a story, it's a reality. Right? Bit by bit. Bit by bit. And showing you what's exactly happening inside the computer. Of course, this is not an easy task. In the very first day, I told you that there are two things which are super complex. That is why we say it's not rocket science. Because we know that rocket science is one of the hardest. So when we want to say that, okay, it's not very difficult, we say it's not rocket science. So what is the other term people can use? It's not computer science. Because computer is the one that processes data. Very complicated device. But don't worry. Computers are built by humans. You are a human. I am a human. So if computers are built by humans, if we are humans, so why can't we understand it? Because we are not donkeys. Right. So now we have set of ones and zeros. Okay, set of ones and zeros. And when we apply arithmetic and logic operations, we get different set of ones and zeros. That is your information or result. So remember, I use two words, arithmetic or logic. But in reality, arithmetic operations can be done when it comes to binary numbers. Of course, for compute, everything is a binary number. At binary level, arithmetic operations can be done using logic or Boolean logic, two-state logic. So that means now it's saying like that. Because arithmetic processing means at hardware level, when your data is in binary, arithmetic operations can be done using logic. And of course, in your topic 4, we will discuss how to design a logic circuit to add numbers for ladders, half ladder, full ladder. Don't worry, we are going to look at it. But so this is very important thing I told you. When your data is binary numbers, arithmetic can also be done as logic. So you can think of arithmetic as a logic. And of course, not only you can think of, you can build those circuits. So therefore, though we say we have arithmetic and logic unit, ultimately what we do is we can say, but if someone asks what is mean by processing, you can say yes, it means applying arithmetic and logic operations. But because arithmetic operations can be done using logic, ultimately you can say that what is mean by processing, you apply logic operations or Boolean logic operations. Why? Because arithmetic can be done using Boolean logic. So therefore, arithmetic is also Boolean logic. Of course, logic is logic. Therefore, if someone asks what is mean by processing, either you can say Processing means we apply arithmetic and logic operations. So that is why your microprocessor has ALU. At the same time, you can say processing means at the low level, apply logic operations, Boolean logic operations. Why? Because arithmetic is also can be done using logic. Right? So now we can see that you can look at the computer in a different it's not different ways. You are looking at the same computer from different levels of details, software level, hardware level. So therefore, for one question now you have so many answers also. What is mean by data processing? Process your data according to your programs, program logic. Or you can say at hardware level, low level, data processing means your data which is represented as set of ones and zero. So we apply arithmetic and logic operations at hardware level or the ALU unit of your processor to get the different set of ones and zeros. Or the third way of explaining it is, yes, our data is set of ones and zeros, and we apply logic operations to get different set of ones and zeros. So why we can say we can apply logic operations? Because arithmetic is also can be done using logic operation. Okay. So these are the most important sessions in your A-level ICT. So once you have your foundation right, that's it. So that is then your time. You take control of your studies. You can just read notes, understand, enjoy your life. Otherwise, what happens? You need the teacher to feed you. Actually, what teacher does is the teacher feed you and memorize you, make it familiarize. So that is where you need 3 hours, 4 hours, 5 hours ICT. Not only one class, I need to go to 2 classes, 3 classes. Why? You don't understand things, you just keep memorizing. And also that gives you a lot of stress, headache. It's not only for ICT, any subject, especially technology subjects, science subjects. So study in the proper way. So then you will feel like the subjects are small and smaller. You are happier and happier. You are very relaxed. That is, if that happens, you really study. Okay, now someone will ask. Someone means someone with logical thinking, someone with critical thinking. Critical thinking and single vichara buddhiya තියෙන. So there are two type of people, humans in this world. There are two type of humans in this world. One type of humans, when they are told something, they just accept it. So when say someone's told you something, you just accept it. Right, okay. But those second category, so that is what I want every one of you guys in. So we say those guys with logic, critical thinking, vichara buddhi. So when someone tells something to this category of people, that is the goal in the society. So they always ask why. How does it happen? And they always question. They always think whether is it logical thing this guy is telling? Is it possible really? Or this guy is telling me a lie? Or this guy is just telling me a story? Right. So now, if you are in this category, so because this category guys always ask why or how. So now I told you that at very low level, you can think of data processing as we have set of ones and zeros representing the data, and it is converted into a different set of ones and zeros. So different set of ones and zeros are generated by applying logic operations. So then I told you that, of course, it is arithmetic and logic operations, but arithmetic is also can be done using binary logic. Okay. But I didn't explain you how your program is mapping to this set of arithmetic and logic operations that we can learn later. So now someone will ask, how does computer apply logic operations to these set of ones and zeros to get different set of ones and zeros. So for that different set of ones and zeros can be interpreted by your software as your results. So now what is the next question you must ask? How does computer apply logic operations to these ones and zeros to get different set of ones and zeros? Right. So those who have done O-level ICT, so you feel like no, I'm a bit of confident about my ICT because you guys ඔගොල්ලෝ උටින් අහසින් පාත්තුනේ නෑනේ A level ICT පන්ති කරන්නේ නේද? ඔගොල්ලෝ ICT ඉගෙනගෙන තියෙනවා, O level වල සමහර ඉගෙනගෙන තියෙනවා. According to your understanding, right? How does computer process or apply logic operations to these set of ones and zeros to get different set of ones and zeros? So I'm not asking sort of a very detailed answer. Maybe just one word will show that okay, you have that idea. I'm not expecting sentences. I'm just expecting at least you throw away some words. If that word is related, I will accept it as answers. So again, I will repeat my question. So I told you that at low level, what is meant by processing, your set of ones and zeros that is representing your data is going or on for those set of ones and zeros, we apply logic operations to get different set of ones and zeros. So my question is, how does computer apply logic operations to these set of ones and zeros? How? So my question is, how does computer apply logic operation? Or can you give me example of a logic operation? Those who have done O-level ICT. So you can't tell me that I don't know this. And of course, even though you have not done O-level ICT, you should be able to answer. Can you give me example of a logic operation? Because now I told you we apply logic operations to the set of ones and zeros to get the result or the information at hardware level. Can you give me one example of a logic operation? Just one logic operation. Just one logic operation. Yes, AND operation. Correct. Perfect. So what are the other logic operations other than AND operation? So AND logic operation. So if someone asks what are the arithmetic operations? Add, subtract, multiply, divide. So likewise, what are the logic operations? Yes, and or what else? What else? Anything? Yes, not. Do you know one more? One more? Yes, other than no, and there's another very important logic operator. So now you have told me if you forget about the known and basic operators and or not, what is the other one? Anyone? What is the fourth one? Just give it a try. Not and or, what is the other one? Other than the no, NAND and no, because NAND and no are special. That is just combining and not, combining and or. Sorry, combining not and no. Yes, XO. Correct. So therefore, what is mean by applying Boolean logic operations on set of ones and zeros? Basically, you are applying these operations, not logic operation, AND logic operation, or logic operation, XO logic operation. And of course, not just one operation, combination of maybe you doing some AND, then or. Part of the data you are applying and another part you apply O, then those two results are again XO. Don't worry. But this is what happens. So therefore, what is mean by applying logic operations? You apply not operation, O operation, XO operation, and so on. So I'm keep asking questions. Today, my task is asking you guys questions. And you guys must give me the answers. Of course, if you can't give me answer, don't worry. But maybe after 1 month, 2 months, so those who are silent also must start giving answers. And others must keep your good work. And the advantage is in a virtual class, you don't need to be shy, right? At the physical class එකනට ලැජ්ජ හිතෙන්න පුළුවන් පොඩ්ඩක් සර්ට පේනවා අනිත් අයට මාව පේනවා දැන් ඔයාව එහෙම පේන්නේ නැහැ මම ඔයා කවුද කියලා දන්නේ නැහැ එක්කෙනෙක් ටෙස්ට් කියලා තියෙනවා එක්කෙනෙක් VP කියලා තියෙනවා බය නැතුව කතා කරන්න chat එකකින් හරියට කතා කරත් ඉතින් ඔයාව පේන්නේ නැහැ වැඩි ඒකට ඇඩ්වාන්ටේජ් එකක් ඊට පස්සේ ඉතින් මාව පේනවනම් හොඳයි මම හොඳට උත්තර දෙනවනේ කියලා අනිත් අයට මාව බලා ගන්න ඕන කියලා මම හොඳට දැන් මම කොන්ෆිඩන්ස් අරන් හැබැයි මුලදී පේන්නේ නැති එකත් හොඳයි කියලා හිතාගෙන බය නැතුව මේවා කරන්න මොකද ඔයා ඉන්නේ Aද Bද කියලා කවුරුත් දන්නේ නැහැ Zoom එකට right so my next question so therefore my task is keep asking questions so try to give me at least one answer each student okay right and don't worry if you make mistake that is perfect because that is why you guys are attending classes if you can give me the perfect answers to each and every question why do you want to attend classes right my next question is yes what we do we apply set of ones and what set of these operations AND operations or operations XO operations and so on to get different set of ones and zeros that is our result or the information remember this happens at hardware level and how do you call those devices or those things that apply NOT operation AND operation, O operation, XO operation and so on. How do we call them? අපි ඒවට කියන්නේ මොනවයින්ද මේ AND operation එක වෙන්නේ? O operation එක වෙන්නේ, XO operation එක වෙන්නේ. There's a word for that. So we say that these things does O operation, XO operation, NOT operation. So how do you call that? That thing or that device or whatever. Because something must do this, right? This can't happen, right? Automatically. So do you know the word that we use for that? So you can then say, this can apply the NOT operation. This apply the AND operation. But there's a standard word in ICT. Yes. So logic gates, right? So there's something called AND logic gate. There's something called O logic gate, NOT logic gate, XO logic gate. So those logic gates can, or when the data goes through the logic gate, so the AND operation is happen, XO operations is happen, NOT operation is happen. So that is really good. And we have given them the symbols also, right? You may have seen this. Of course, you guys are not right fallen from the sky. There's something called AND gate, O gate, NOT gate, XO gate. So when your data goes through these logic gates, or when your set of ones and zeros going through your logic gate, for example, when this is 0, this is 1, this is 0. Because in AND gate, both are 1 only 1, or both are true only true. But if it is something like this is 1 and this is 1, then of course the output is 1. But if it is O gate, when this is 0, this is 1. In AND gate, this is 0. But in O gate, 0, 1 is 1. So that is how the O logic operates. So now you know that what is meant by processing. Your data, which is represented as set of ones and zeros, are applied logic operations to get different set of ones and zeros. And what is meant by applying logic operations? Applying AND operations, OR operations, NOT operations, XO operations, and so on. Sequence of those. And which device do that? Logic gates, AND gates, O gates, and we have given them symbols also. So my final question, otherwise you may feel like, okay, these guys keep asking question forever. So this is my final question. And this is little bit Oh, again, if I ask a question, I expect answer. If I don't expect an answer, I will say I'm not expecting answer. If I get an answer, it's a bonus. But this is something I expect an answer because you should have learned this in your O level, right? So how do we build these logic gates? Because this is a conceptual thing. There's no physical device called AND gate. You can't touch an AND gate. You can't touch OR gate. Right? You can't touch XOR gate because this is a conceptual thing. But these conceptual things at hardware, we can't have the conceptual thing. Ultimately, we must see the physical thing. So my question is, so this is my last question. Don't worry, I'm not going to ask any more question. How do we build AND gates, OR gates, NOT gates, XOR gates in electronics? Just tell me one word, that is enough. How do we build? And it's a physical thing. It's a physical thing you can touch. And of course, you can go and buy. Electronic shop, you can go and buy. So if you can go and buy, it's a physical thing, right? But you can't go and buy AND gate. So when you go and buy AND gate, what they give is basically these things. Okay. How do you call it? Yes. Transistors. Correct. Yes, circuit is correct. But if you go into the what is inside the circuit, it is transistors. So how do scientists, engineers build AND gates? Using transistors. How do we make OR gates? Using transistors. How do we make NOT gate? Using transistors. So we can build AND gates using transistors. You can build OR gate using transistors. And transistor is an electronic device. Transistor is an electronic device. Of course, early days, gates were built using some other devices called vacuum tubes. But these days, logic gates are built using transistors. Okay, transistors. And of course, your microprocessor, especially the ALU, has millions of logic gates or circuits having millions of logic gates. Of course, it doesn't mean that your every data is going through each and every circuit. No, it goes through the relevant circuit according to your logic in the program. Right? So therefore, your ALU has millions of logic gates, AND gates, OR gates, NOT gates, XOR gates, and so on. So that means because logic gates are built using transistors, your microprocessor, very specifically ALU, has billions of transistors. So just pay attention to my words. Your ALU has millions of logic gates. But logic gates are concepts. Physical, not physical things. So these logic gates are made using transistors. So therefore, when you have millions of logic gates, you have billions of transistors. Billions of transistors. So then someone will ask, when you have millions of logic gates, why do you need billions of transistors? So again, if you are a logical thinker, you can give me an answer. So at the end, you must be a logical thinker. Use your common sense. So when you have millions of logic gates, and if you need billions of transistors to build that, what kind of things you can get it from there? So that means to build one logic gate, you may need multiple transistors. Logic gate 100ක් හදාගන්න transistors 300ක් ඕන නම් 1000ක් ඕන නම් ඒ කියන්නේ logic gate එකක් හදාගන්න එක transistor එකකින් බෑ. සමහර එක transistor එකකින් බෑ. ඒ කියන්නේ transistors කීපයක් ඕන. දෙකක් තුනක් එකතු කරලා තමයි එක logic gate එකක් හදාගන්නේ. Okay. Okay. So see whether these are correct. ඇත්ත පොඩ බලන්න ඕගොල්ලෝ මේ ඇත්තද මේ කියන්නේ බයිලා ගහනවාද? Skip on it. So let's take something like i7 processor. Okay. So my laptop, I'm running on i7 processor, or we can say i5 or i3 or whatever, or it, maybe some other processor, Motorola or whatever. How many logic gates in the, say, i7 processor? Of course, that number is getting bigger and bigger. At 450 million logic gates. 450 million logic gates. Right? Gates means logic gates. Okay. Then how many logic gates are in a typical computer? Right. So that is 450 million. Million means what? So this is 450 million. So 1 million is this. So this number of logic gates, AND gates, OR gates, of course, combination of these things, right? NOT gates are there. Right. And to create this number of logic gates, so they need about 1.4 billion transistors. Because it says, let's assume on an average, one gate uses 3 transistors. On average, because different gates need different number of transistors. So on average, if you think that one logic gate, to build one logic gate, you need 3 transistors. So if you multiply this by 3, of course, there's another 0 there. That is why the million become billions, because this, when you multiply it by 3, it is 1.2 something, right? So therefore, you need over 1.4 billion. 1.4 billion. This is millions, 450 million. That is 1,000 millions. Okay. Over 1.4 means 1,000 millions of 1.4 billions of transistors. Okay. So why do we need transistors? Because transistors are used to make logic gates. Why do we need logic gates? Because at hardware level, your ones and zeros are going through the logic gates, because we need to apply the logic operations. Because ultimately, arithmetic operations are also logic operations. Now, do you have a better confidence about what is computer before you attend the class? No. After attending the class for 1 hour. That is what we want to make you. Day by day, you must be more and more confident. So when the exams are nearing, you must be really waiting for the exams, not running away from exams. Okay. So now again, of course, I promise you that I'm not going to ask any more questions. Okay, I'm not going to ask any more questions. But anyway, if you are still thinking, maybe some of you guys had this question in your mind, or having this question right now. So this guy is telling that there are ones, your data is set of ones and zeros. So I told you that let's assume it, accept it. Okay, you are very humbly accept it. Okay, so our data is set of ones and zeros, and this guy is telling that there are AND gates, OR gates, and combination of these things, right? And maybe another AND gate, and then there's OR gate, and so on. So this guy is saying that these set of ones and zeros are going through these gates or the circuits and get a different set of ones and zeros. So then, can you explain? Okay, how does these set of ones and zeros, when they're going through these circuits, how can it really happen? Is it possible? So what is mean by sending ones and zeros through an AND gate? What is mean by sending 1 and 1 to AND gate and saying that 1 and 1 is 1, and saying that 1 and 0 is 0? But if it is OR gate, 1 and 0 is 1. And if it is a NOT gate, when this is 1, this is 0. And what is really happening? Because 1 is a concept, 0 is a concept. You are talking about the hardware. At hardware, what is mean by one, because one is not a hardware concept. One is a concept. So what is mean by sending one and zeros, set of one and zeros, or my data through circuits? What is really happening inside that? So once you understand that, so that's it. That's it about getting the overview of what is computer. That is the purpose of this topic. What is a computer? Or introduction to computer. Think about it. Think about it. So if someone asks, right, you guys saying that you represent data as set of ones and zeros, and you guys saying that we apply logic operations, okay, I'll accept that also. And that means it's going through different circuits having logic gates like AND gates, OR gates, and so on. Okay, I will also accept that also. And you guys saying that these AND gates, OR gates can be built using transistors. Okay, I will accept that also. There's something like that in electronic. So the next question you must ask is, how do you send ones and zeros through physical transistors? Because you just told me that AND gate can be built using transistor, OR gate can be built using transistor, and blah, blah, blah. Transistors are something physical, like the resistors, capacitors, and so on. So how do you send ones and ones through a physical transistor? For logic gates made of transistor, because it has wires, input wires, and two input wire and output wire if it is AND gate. So how do you send ones and zeros through wires? So that should be a valid question, right? For a critical thinker, that should be a valid question. Of course, you must also ask that question by yourself. Otherwise, you are not a critical thinker. You just accept things. And you are not confident then, because you have accept things and some there are gaps. Okay. So do you have an answer for that? Do you have an answer for that? By on and off method, through a high and low voltage current. Yes. So in a way, both has a bit of meaning. I think through high and low voltage current is, I maybe we can combine those two answers to get a better answer. Right? Maybe we can combine those two answers to get a sort of a more comprehensive or more meaningful answer. Okay, right. So this is the simple answer. Basically, I'm repeating your answer, but I just want to sort of connect those two answers. So remember, I told you that computer is a digital electronic device. I told you, and again I told you that electronic means either generating signals, processing signals, or using signals. And the computer is a digital electronic device, so that means it generate, process, and blah 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 digital signals. So far, we have not mentioning about digital signals, right? So far, we are talking about data is ones and zeros. You have the logic gates, right? And logic gates are made of transistors, but so far, no, I have never ever mentioned about where is this signals, because otherwise, why do we call it electronic device, digital electronic device? So the idea is not the idea, this is what happens. So remember, computer represent your data as set of ones and zeros. So then to represent that set of ones and zeros, that is your data, it generates a signal to represent your set of ones and zeros. For example, when your data is read from your hard disk or SSD, it is set of ones and zeros. So then your computer can generate digital signal for that. Digital signal for that to represent that set of ones and zeros. Okay. Say your data set of ones and your data is one part of the data is 1001101. So then it generates something like 1001101. 1001101. Maybe another data, maybe you want to add two numbers. Maybe the other data is in binary level, other data. Okay, so I will draw it here. 110101. Maybe that is 1, 1, 0, 1, 0, 1. Likewise, now you have for each and every data, you have corresponding digital signal. That is where the electronic comes. So then what happens is, when these signals, because remember your gates or the transistors have wires, right? Copper wires. When these signals goes through, these signals are representing different data. Sometimes two signals, because two input and one output. It gives you a different signal. So that is how you have, we say that it is a digital electronic device. Okay. Of course, this is just one logic gate. So then this output and maybe another processing part goes to another OR gate and so on. And ultimately you get final digital signal. That is the final result or the information. After going through all the relevant circuits, of course, which circuits your signal goes to is high level determined by your logic program, Python program, Java program. So that is what happens. Okay. So then someone will ask, when two signals goes through a logic gate, how do you know what kind of signal is generated? Super easy. For example, in order to understand that, you must know what is AND gate, what is OR gate, what is a NOT gate, because you guys must know what is AND is, what is OR gate is. You are in 2024. So that is why you have so many ICT teachers in your school. So that is their task, to teach you what is AND gate, what is OR gate. Otherwise, right, so they should not get their salaries. So you are supposed to learn a bit of ICT from grades, even grade 4, 5. Right. If it is AND gate, what is the logic? When both are true, only true. That is what we AND, right? So when they say you must bring your admission card and ID. So if you just take your ID, you are not supposed to face the exam. You just take your admission card, not the ID. No. But if you take both, yes, you can face the exam. That is what AND logic. When both true, only true. Otherwise it is false. That is common sense, right? But if it is all logic like this, when at least one is true, it is true. When both are false, only false. So that is, this is true, this is true, this is true, only this is false. It is something like saying you must have a ticket or season to use public transport. You have both ticket and season, you are good. You have ticket but no season, okay. You have season but no ticket, yes. But you don't have anything. Now you are in trouble. Of course, this is a crazy thing, but you are not in trouble. That is a logic. Okay. Now assume this is AND gate. Of course, this is a symbol for AND gate. This is AND and this is O. Okay. And you know what is the logic? What is AND logic is, or AND operator is? When both are true, only true. When at least one is false, it is false. Or we can say, rather than true, false, when both are one, only one. When at least one input is 0, for both 0, it is 0. Now let's assume this is your sort of a data, and to that we have created a signal. So this is your other data. For that also we have created a signal. And now what happens is those two signals, because signals, now we have generated the signals, those two signals are fed to this particular AND gate as part of a circuit. As part of a circuit. Say this is the first clock cycle or first sort of a time unit. Say it is both 1. Sorry. So let's say it is this data, it is 1, this data, it is 0. And you know that when you have 1 and 0, the result is 0. Because that is how AND logic works. Right? So that is what that is how AND logic works. So therefore, output signal for this particular time slot, the output signal will be 0. Because 1 and 0 is 0. maybe this is I keep sending the first data, this is I keep sending the second data parallel, because we want to process those two data, like adding two numbers. Okay. This is just part of the circuit. Maybe this output is sent through another gates and so on. Now let's say the second bit for the two data, this is 0, this is 1. And at this particular time slot, we got 0 and 1. 0 and 1 is what? Again 0. Because this AND gate. Let's assume this AND gate. Therefore, it is still 0. And let's say in the third clock cycle or the third time slot, your first data value is 1, second data value is also 1. When 1 and 1 goes through, or high and high goes through AND gate, high and high means you have the voltage. You have voltage in both inputs. Now you have a voltage in the output, because 1 and 1 is 1, or 2 is 2. And this keeps going on for the two data streams. Say, I'm just giving sample data. Say 1 and 0, again 0. Maybe 1 and 1, that now again 1. So we can see that we have two set of data, or the digital signal corresponding to the first data, this digital signal corresponding to second data. When those two digital signals fed to the AND gate in a time synchronized manner, so that means these time slots must be properly synchronized, and it gives you a different signal, and that is the output of that particular two signal for this particular operator. Of course, this is just a part of the circuit. Your circuit will have something like first AND gate, then you have it. It goes to a NOT gate, maybe another. This signal again going through another XOR gate, and so on. So this is how do you design this circuit. That is our part of our topic number 4, data processing, logic circuit design, digital circuit design. But today itself, learn how does computer process data, and in the future, why are we learning representing data in the computer, digital circuits, logic gates. So today itself, now actually you must have the big picture. Now you must have the big picture of what the computer does. What the computer does. And I'm not saying that you know A to Z about how the computer processes data, but all view at each level, from software level to the logic gate or even transistor level. So how does transistors are used to make logic gates? So that is little bit beyond our syllabus, because we are not doing electronic, we are doing ICT. Right? We are doing IC. So therefore, it is little bit beyond our syllabus. But when we learn about logic gates, we will have a look at it. Right? We will have a look at it little bit, not seriously, because they are not going to ask from you guys how the transistors are used to make AND gates and NOR gates. But we will have a look at it, because otherwise there's a gap. But not now. Not now. Okay. Maybe if you are curious, you can do a search. Of course, you must be curious, right? So that is why you must be learning. So you can do a Google search, or you can go to the YouTube and search, how do we make AND gate? How do we make OR gate? How do we make NOT gate? Or because you know that, now you know that we make gates using transistors. You can say how to make AND gate using transistors. So how does that, first of all, you must know what is a transistor is, if you want to understand that. But let's not get into that level of discussion right now. But maybe when you have free time, you can do it by yourself. Because some of you guys have some real interest about the electronic, right? So then, of course, we are living in the era of ICT. So if you can't explain what is a transistor is, that is really, you must be really ashamed of. Because we are living in the era of ICT, and sometimes we say we are in silicon age. Silicon, because we use silicon to build transistors. That is why USA there's a area called Silicon Valley. That is where most of the IT companies are, like Google, Microsoft, Oracle, Silicon Valley. So Silicon Valley is related to hardware. Silicon is used to build transistors, and transistors are the building block of your microprocessor, logic gates. But anyway, how does your transistor work? Or how to make AND gate using transistors and blah blah blah. Just let's keep it for the different day. Okay. But now you must know when you get this kind of two signals through a gate, it generates a different signal, depends on whether it's AND gate, OR gate, or so on. So that is how we have set of, this is maybe my first data, other data, maybe this is my resulting data. But of course, that is after going through so many gates based on your logic. Right? Any question? Any question up to this point? So don't lose the big picture, right? What is data? What is information? What is entity? Right? The thing that we discussed in the very first day. What is a system? And what is computer? What are the features of computer? Computer is a data processing device. Computer is a digital electronic device. Computer represent everything in as set of ones and zeros. Computer process everything using logic gates or more specific transistors. Now you must have more and more things to tell. And you must be more and more confident day by day. So day by day, you must be more and more confident. Do you know that when the A-level exams are nearing, so there are some students, they get blank. It's like a formatting. It's like they are formatted. So then the parents take them to the doctors saying that, okay, this guy says, all of a sudden, this guy can't remember anything. Exam is 3 weeks away. Why? So they keep memorizing without understanding. So they get more and more stress, more and more stress. But if you properly study, how can you be stressed when you know more and more, when you understand more and more? You must be more and more happier, right? So that is what is meant by study, proper way of studying. Right. So therefore, I already explained you that your data is processed by your microprocessor. Microprocessor is having logic circuit components. Specifically, your ALU has logic circuit components. We will discuss what are those logic circuit components later on when we discuss the topic 4, like adders, encoders, decoders, multiplexers, and so on. And these components are made of logic gates, AND gates, OR gates, XOR gates, not gates, and so on. And these logic gates are made of transistors, which we did not discuss much, how logic gates are made using transistors, because that is for the electronic students. Or maybe if you are doing other technology subjects also, maybe, yes, you will learn it in your other subjects. Okay, more and more. That is why you have multiple subjects. But others, don't worry too much. Right? If you are doing ICT with some other combination of the technological subjects, don't worry too much. And also, if you are doing physics, definitely you will learn how the transistor work is built on the physics subject. We have the electronic parts. But others, don't worry too much. But anyway, we will have a look at it at high level, how the transistors are used to make logic gates. So actually, there's a little bit of theory behind that, but not today. Okay, not today. Right. So we use the word logic gate, right? Logic gate, AND gate, OR gate, XOR gate. Why do we call them logic gates? Logic gate, AND gate, OR gate. So you must know why people give their names like that. Of course, the word logic is there. So that is why we say AND logic, OR logic, XOR logic, not logic. So then why do we have concept word called gate? Because AND gate, we say this is an AND gate. And we can make AND gate using transistors. And this is OR gate, this is symbol for gate. And why do we call it a gate? Of course, logic, because these gates operates on logic operators like AND operator, operator. Why do we call it gate? Because someone can ask you, right? Then you can't say that is how the people have called it for the last thousands of years. So let's continue that good tradition. So that is you are crazy guy. Your faith, you're stupid basically. So what is what is mean by gate? So gate is used to, we can close the gate so that no one can go through, or if the gate is open, anyone can go through. So the only thing is these are electronic gates. So therefore, what can go through and what can't go through is electricity or the electrons. Electrons. So either it allows electricity to go through, or it will not allow. For example, if it is AND gate, we can make it in such a way that when both inputs have electricity or high voltage, then only your output has high voltage. The moment at least one signal has low voltage, that is, this is one, but now this is still one, but this is zero. Now, of course, this is going to be zero because it's a gate. Gate is either open or closed. Now the gate is closed. So therefore, electricity can't go through it. So maybe in the next clock cycle, again, your gate is on. Maybe because both inputs are one. And maybe next time both are zero. Again, your gate is zero. And so on. So that is what is my logic gate. So it determines or it either allow or not allow electricity to flow based on logic. And logic, or logic, XOR logic, not logic. So you must be really confident, right? So if someone asks, why do we call it logic gate? Why do they say the word gate? So now you must have, right, solid answer. Solid answer. Right. So remember, we are still in the discussion of introduction to computer. So at the end of this session, of course, today we want to finish this introduction to computer. So you must have a reasonably good understanding about what is computer. So remember, now you must have reasonable good understanding about what is information system and what is computer-based information system. So similarly, so your computer-based information system so cannot exist without a computer. It's like the physical body and the soul. The physical body is the computer, soul is the information system. Right. So still we talk about what is a computer, what are the features of computer, right? Now you know that computer is a data processing device, computer is a digital electronic device, and how the computer process data at high level, low level. And also remember, computer is a complex device. Why? Number one is processing conceptual things is not easy because that is something that we used to do in our brain. Processing physical things is relatively easy. That is why making a blender, a washing machine, right? It's not that difficult compared to computer because we process physical things, coconut, water, dirty cloth, or most of the devices are just transforming one energy to the other. Electricity to heat like a iron or what heater, or electricity to the mechanical power like a fan. But this is, we are processing data, numbers, characters. Therefore, obviously, it must be a complex device. And add to that, computer can process not only one type of data, different type of data. It can process numbers like a calculator. It can process text, text processor, image, audio, video, it's a multi-purpose device. Otherwise, what should have been the reality? So you have a calculator, text processor, audio processor. Maybe you are having 5 or 6 different machines. So to process images, you take your image processor. To do your text processing, you take your text processor. To do the calculations, you take your calculator. But that is not the case, right? So you have your smartphone, laptop, desktop, and it does all the things. So when it's something like you have about 5 devices in one machine. Text processor, number processor, or the calculator, image processor, audio processor, video processor, and it can do even some other processing like taking from sensors. So therefore, obviously, it's a complex device. Not only it processes conceptual things, it processes different type of those conceptual things. So therefore, it's going to be complicated. That is why I told you that when there's a very complicated things, you can say, not only you can say it's not rocket science, you can say it's not computer science. So because this is so complicated device, of course, not everyone can build computers. That is why those companies that build computers are very rich. So when we say computers, what is which countries comes to your mind? When you say computers, which country comes to your mind? And that country is the most powerful country in the world. And a lot of people say that they earn money by war. No, they don't earn money by war anymore or selling weapons. So they earn money by selling computers, computing devices, and software services. So you name it. Apple, Dell, Intel, AMD, microprocessors. Then networking. Then software side, Microsoft services, Facebook, Oracle. So you name it, they are all from USA, America. So that is how they make money, majority of money. And of course, it's a complex device. So that is why only the best of the best people can build it. And how do they tackle this complexity? So they use component-based architecture. Because computer is so complicated device. So how do we build modern computers? We build it as set of components which are communicating and collaborating through well-defined interfaces. Because it is too complicated for one company, one manufacturer to manufacture it. It's collaboratively built. Right? Collaboratively built. If you take your laptop or your smartphone or your desktop, so I have a Dell laptop. So my motherboard may be Dell. I sometimes even doubt whether the motherboard is also not Dell. Maybe some Taiwan motherboard company. My microprocessor is Intel. It's not manufactured by Dell. It is manufactured by Intel, another company. My SSD, another company. Maybe my display panel is Samsung or LG. Of course, you don't see their brand, but they'll buy from them and they use it, display panels. So likewise, it's a set of components. Right? SSD, RAM chip, processor, input devices, output devices. If it is a desktop even, you can change your monitor, keyboard, mouse. So it's used component architecture. Then only that complexity can be handled. And it's different manufacturers, experts in different devices. Okay. So in general, you can identify your hardware components as very high level, input devices, output devices, storage devices, and processor. So that is high level. But inside, something like processor, there are subcomponents. For example, processor has ALU, control unit, registries. So this is how you look at the hardware. Remember that we have the layered architecture, hardware, firmware, software. So at hardware level, this is how you look at the computer. Now you can see that it's a set of components. It's a set of well-defined components. Actually, this is called von Neumann architecture. Von Neumann architecture. You will learn about von Neumann when we discuss history of computing or evolution of computer. That is the second topic in your introduction to computing. Okay. Right. So these are the components. So we have the input devices, output devices. So input devices like keyboard, mouse, touch screen. Output devices, your screen mainly, then printers, speakers, and so on. Obviously, you need to have the processor, or we call it microprocessor or CPU. All people call it CPU. The new generation call it processor because new generation like to keep things simple. So then you have the RAM or the main memory. Main memory. So the ROM is there inside your connected to your motherboard. And your secondary storage, that is your these days mostly SSD or hard disk. Or maybe you have both. One partition SSD, other one maybe hard disk. And the tertiary storage, backup storage like pen drives, CDs. And this is how you look at the computer as a set of components that communicate and collaborate. So it's very important to understand computer as a hardware device using this picture. And remember that, and don't forget the layered architecture, right? Hardware, firmware, software. Our software you can subdivide into two and of course the users. And this is how you look at your hardware. How you look at your hardware. Okay. So remember our task is look at simple things in a serious manner. That is why you are in advanced level. And if you get into a degree level, right? So you will get into the next level of seriousness. And of course, they will filter out and get the best students to the degree level. Others will be filtered out. So that is part and parcel of the life, right? If you are not serious enough, of course, you can't go to the next. Because only the more serious people should be the doctors. Because they are taking care of lives. So if someone is not as serious as expected, of course, he or she should think, okay, I'm not serious enough, so I should not take that kind of big responsibility in my life. Let someone with more seriousness take that kind of a responsibility, right? Rather than you somehow try to be a doctor. Same thing. Okay. Of course, you can improve your seriousness. That is one different thing. But if you are not serious enough, don't try to get into serious jobs. Because then not only you are in trouble, others are also in trouble. Right. So therefore, let's try to be serious as much as possible, but you must know your limitations as well. Right. So now you must have serious answers to these questions. What is an input device? What is an output device? Serious answers. Serious in the sense for advanced level student. Okay. Sometimes when someone asks a question, you might feel like, okay, I have answer. I'm done. But maybe someone else has a better answer. So that is why when you go for an interview, right? Maybe they want two engineers, two software engineers, but they ask for about at least 15 of people for the interviews. And they interview each and every of those. And ultimately, they pick maybe one or two. So who are the guys who are selected? Out of these 15, of course, the 13 will not be getting the job. Maybe they can go to another interview and get the job there. And they might have a chance. So which guys are selected? The two more serious guys. because they want to get serious things done. So out of these 15, they want the two more serious. Two more serious. So therefore, it's very important that you become a serious, okay? Right. But anyway, you may not be able to give the perfect answer, but be serious. Think little bit beyond. Don't settle for whatever that comes to your mind first. Think whether maybe that is good answer. Can I make it better? Can someone else come up with a more serious answer? Then I'm in trouble in competitive world. So if I and this guy go to the interviews, this guy get the job and I come home without anything. So therefore, think twice. As much as possible, be serious. But serious doesn't mean that you live like having a headache. Seriousness is not having a headache. Do you think that the doctors have always headaches? No. It's just you are serious than others. Right. So if someone asks what is input device, what is input device? So most of the time, the simple answer we get is input devices are used to input data. I know that majority of you guys may have thought that as answer. Input devices are used to input data. But little bit more serious answer is not little bit more serious. If you go and if you go for the interview, I also go for the interview. They are going to select only one. So you go and say input devices are used to input data. I will go and say input devices are used to input data and commands. Because I know that data and commands are two different things. For example, when I click here, I am giving command. Make it red. Make it blue. Right? Now it should be in blue color. Now I will give a command saying red. Now it should be red. So that is not data, that is command. Okay. Or I will say save. It's a command. New command. Those menu options and so on. So therefore, don't think that we use input devices only to input data. So what is the input device? Input device is used to input data and commands. So that is why you have the enter button. Your mouse is mainly used for giving commands. So that is what input devices are all about. Input data and commands. Then what about output devices? Like your screen, monitor, speaker. Output, yeah, correct. So output devices are used to display or provide or output results or information. So output devices are used to output what? Results or information. Maybe your input device, you say 5, 2 and add. And output device now it says it's 7. So 5, 2 are data. Add is a command. Add this command. Now you have 7. That is your information or the result. It's a just simple thing, but that is what happens, right? Right. So then what about the processor? Or microprocessor or CPU, central processing unit in good old fashion? Now, do you have serious answer? What is processor? What does your processor do? What does your processor do? Obviously, processor must be doing processing, right? That is obvious. That is why we call it processor. But it does two things. Processing and what is the other thing? Anyone? Processing and control. Just like our brain also doing the both. So our brain does all the processing and controlling. Do you know that there's a health issue called, how do you call it? Paralyze. Answer again. paralyzed. So what is the symptom? So maybe that guy can't move his or her arms, legs freely. But is it the issue with arms or legs? No, issue is brain. Blood, right? Clot in the brain. And that part of the brain is not working. Because that part of the brain is not working, that guy can't control part of the body. So therefore, remember our brain does not only processing, controlling. So same thing in microprocessor or processor does two things, that is, does the processing and controlling. Of course, registries are used to help processing. Okay. So therefore, your processor, if someone asks what is the purpose of microprocessor, microprocessor is used to process and control. Process and control. Okay. Process and control. So give the perfect answers. Right? Be the number one, not number two or number three. So your answer must be the world's best answer. Right. So then we have RAM. Okay. Okay. Forget about the RAM. Then we have the secondary storage. Okay, secondary storage. What is the purpose of secondary storage? Secondary storage is either your SSD or hard disk. Right? Either your SSD or hard disk. Or sometimes you have both the SSD and hard disk. Part of the things are in your SSD, other things are in hard disk. Now again, the common answer is, right? That is non-serious guy's answer is secondary storage is used to permanently store data. If you are a little bit serious, you will use the word permanent, which is good. But because if you are very casual, you will just say, just like you say input data for the input devices. I told you not only input data, you input commands also, because commands are not data. So similarly, secondary storage is used to store what? Store what? Yeah, I already got that answer, right? To store data permanently. So that is the casual answer. I'm not saying that is wrong. But while all the others says, right? All the others say permanently store data, permanently store data. You go and say, and you will shine. What do you say? Secondary storage is used to store data and programs, because you know that programs are not data. Data and programs. So if you have any doubt, so this is my secondary storage. This is my secondary storage. And it has a Windows folder. This is not data. This is my operating system is saved there. Operating system is a program. And then under programs, files. So there are so many programs. Actually, in my C drive, right, 80% of my storage is taken for programs, not for data. Of course, if I have saved some Word documents, PowerPoint presentations, that is data. Text documents, images, audio, video, that is data. But this is not data, this is program. So therefore, what is the proper answer? Serious advanced level students answer. So we use secondary storage to permanently store data and programs. All your data and programs are there. Data you have saved, programs you have installed. Okay. Right. So then what about the tertiary storage? That is called secondary storage. Tertiary, third level storage. So that is your offline storage. Maybe you want to take backups, or you want to offline take it to somewhere else, not through internet or network. Take to a pen drive and go and save it in another machine. Or you just want to backup it, like put it into a CD and keep it. So that is called tertiary storage, like your pen drives, especially CD, DVD. These days, of course, CDs and DVDs are getting less use. But definitely your pen drives, external hard disk. So that is called what? Tertiary storage. Again, you can keep data and programs. Of course, not install program. Maybe you just want to back up your programs. Right. So then we have the ROM, read-only memory. So can someone tell me what is the purpose of ROM? That is simple answer. Read-only memory. Those who have done bit of O-level, not bit of O-level, those who have done O-level ICT, definitely you must be able to answer. Of course, if you have not done O-level ICT, don't worry, right? So maybe first month, 2 months, you will feel like you are a little bit behind, but after 2 months, 3 months, everyone will be in the same level. Because in the O-level ICT, they have not taught you everything, just the basic things that we discuss in topic 1 and 2, maybe little bit of topic 3. But beyond that, everyone is in the same level. Right, ROM is used to keep the firmware. Remember the layered architecture, we have the firmware on top of hardware. I told you firmware is theoretically programs or software. But because they are more related to the hardware, running the hardware, we just call it firmware. So therefore, ROM keep your firmware. But if you want, you can elaborate on what is meant by your firmware. But basically, it is keeping your firmware. But if you want to make it a little bit more specific, your firmware includes BIOS and CMOS mainly. Right, that we can discuss later. Okay. Right, so then you have the main memory or the RAM or primary memory. Main memory, different name, same thing. RAM or primary memory. That is in your motherboard, there's a RAM slot. There you can fix RAM chip. It's an electronic chip circuit with RAM. So what is the purpose of RAM? Again, you can give a casual answer or you can give the best answer. So if you feel like I have the best answer out of these people, so you must be really proud of yourself. You must be really confident about yourself. So you go there to win, not lose. You go to interviews to get the job. You go to a competition to win, not to lose. Of course, you can't win all the competition. That is fine. Let others also win. But you also win in some areas. Don't be a loser, right? All the time. Have your share of wins. Don't let only others win and you always lose it. Find your strengths and see whether you can also be a winner in maybe 1 or 2 areas. Again, so the temporary store data. So what about programs? You always forget about programs, right? For example, in my computer, I have 8 GB of RAM. I can go to the task manager. And go to the performance. And this is my RAM memory. I have 8 GB of RAM. And out of 8 GB, right now it has used up how much? Yeah, about 7 GB. About 7 GB. 1 GB is still there. And out of this 7 GB, I'm pretty sure at least about 4 to 5 GB is programs. Right? Out of 7, no, not 4 to 5, more than 5 GB program. For example, out of now it has taken up about 7 GB. Out of 7 GB, at least 2 GB is used up by operating system. Not the entire operating system is loaded. Good part of the operating system is loaded. That is the first thing that happens when you boot up. So that is not data. That is the operating system. Operating system is a system software. Then every time you run a program, your memory will increase. For example, if I run Chrome, you will see this line goes up. Okay, look at this line. Right now it is like a flat line. But if I click on Chrome, and all of a sudden you can see it goes up. Right? Why? because now I just run Chrome software. Chrome is a software, no web page, nothing, no data. It's a program is now running. Chrome software is running. And if I close it, again that memory will be released. Again that memory is released. So that is, of course, when you run your Microsoft Word, first the Microsoft Word software, part of the memory software is loaded. And of course, your document is also loaded. So your document is data, your particular Word document, or particular PowerPoint document. But first it load the software, part of the software, not the entire software. That is essential to executing. So therefore, when someone asks what is the purpose of RAM, don't say, right, it store only data. So it temporarily store currently running program segments and related data. So that is the perfect sort of answer. Not all the programs are loaded to memory. For example, I have Photoshop, but I am not running. I don't run Photoshop right now. So therefore, definitely Photoshop, any part of the Photoshop is not in the memory. But the moment I click and run Photoshop, then part of the Photoshop software is in the memory, RAM. So therefore, what is the sort of a correct answer? So your RAM keeps currently running program segments, not the entire program. Because then your RAM is going to be not enough. Only essential programs and related data. Sometimes not even the entire document. Maybe your Word document has 110 pages. Maybe in the RAM, now you are just having about 10 pages that you are just scrolling. In the background, they will stop it. That is what RAM is. That is what RAM is. Again, what is the purpose of RAM? It is used to keep currently running program segments and related data. And finally, we have the processor. Remember, the processor can do two things, or it is supposed to do two things. Does the processing and does the controlling. Entire computer is under control of the controlling unit. Of course, it is indirectly handled by operating system. But hardware level, it is a control unit. And ALU does the processing. Remember, ultimately, it is all logic processing, but high level, it is arithmetic and logic processing. But ultimately, logic processing with the help of logic gates with billions of transistors or millions of logic gates. That is how you look at the computer hardware. That is how you look at the computer hardware under component-based architecture. Set of components communicate and collaborate to achieve the common objective of processing data into information. Any question? Any question? No question? Yes, I know that it doesn't mean that you know A to Z about computer, but before you attend the session and by now, there must be a big difference in your confidence about the computer. Okay. Right, so we'll finish this discussion. We need another about 15 to, actually we need about another 30 minutes to finish this discussion, but we'll do that next time. Then again, we'll move on to the, maybe we can do the evolution of computer. That is the second part of this topic. Remember, we have the evolution of computer also. That is, so now we have not finished this. Maybe we can finish this and then move on to the evolution of computer. Then two parts are over from second. Then definitely we'll come back and finish the first parts, rest of the first part. And then only we'll get into the computer architecture, input output devices. And here we go into details. Okay. So then all of a sudden, two topics will be done. Okay. And the third topic is the data representation. That is where you learn how. Now I told you that just assume that everything is set of ones and zero, but how it is happened, or how to convert your number into a set of ones and zeros, your image into a set of ones and zeros, your audio into a set of ones and zeros. That is something we discuss in that topic. And fourth topic, remember I told you that your signals going through the gates and circuits. exactly how these things are happening in little bit more detail, more serious level, we'll discuss under fundamentals of digital circuits, right? Logic circuit design and so on. Then, of course, we'll move on to operating systems, then the network. Of course, when we are into the network and blah, 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 we are into the middle part of your syllabus. Okay. Right. So, any questions you are having? Because today's session is super, super important. Right? Super, super important. Right. So, if you have any questions, you can keep asking. You can use the WhatsApp group to discuss among yourself also if you have any questions. So, you can ask questions, send me messages. I will always respond. Okay. Right. So I hope you guys, all of you guys have access to the Google Classrooms. Okay. Uh, Google Classroom access, and also the recordings are gradually added here. The first 3 days of recordings are there, but don't rely on the recordings. Don't worry, these recordings will be there when you are going for the exams also, right? Definitely. But don't rely on the recordings. Make sure you attend the session, because just if you can't allocate 2 hours per week, you have only 3 subjects, so that means you are not committed. If you can't have that kind of a commitment, right, so that means your attitude is not good. So just minimum, right, bare minimum 2 hours per week. How many hours you have? 24 hours into 7. So can you allocate just 2 hours for your A-level ICT subject minimum? Right, we stop at this point, right? Thank you.